Assalamualaikum and hello everyone. Welcome back to my channel. How are you today? I hope you are doing well and ready to learn new topic for today's lesson. Today, we are going to learn about specific heat capacity. Now, let's look at our objective today. So, what are the objectives that we are going to obtain from this lesson? The first objective is at the end of the lesson, you are able to understand the concept of heat capacity through questions shown by the teacher. The second one is you are able to explain clearly the factors that affect the heat capacity, which are the mass and the type of materials. And the last objective is you are able to define specific heat capacity of different material through example. Okay, let's see the diagram here. This diagram shows two different situations where the boy with the cap said, "Ouch, the sun is hot," while the other boy said, "The seawater is cold." In this situation, the sun heats up the sand and the seawater at the same period of time. However, the sand gets hot quickly and seawater gets hot slowly. Why this happen? So, this is one of the question and we need to answer in this subtopic. From here, I will introduce the sentence for you first. Okay. The sand has a low heat capacity and gets hot quickly, while the seawater has a high heat capacity and gets hot slowly. So, the physical quantity that I will introduce first is the heat capacity. The low heat capacity means they gain heat faster, so they will get hot faster, while high heat capacity means they need more heat to warm up. It means that they will hot slowly. So from this diagram, the sand has a low heat capacity and it takes shorter time to heat up, while the seawater has a high heat capacity and takes longer time to heat up. Okay, next, what is heat capacity? Heat capacity of an object is the quantity of heat needed to raise the temperature of the object by 1 degree Celsius. So, the key point that I have highlighted here is the quantity of heat needed and the temperature, which is 1 degree Celsius. Okay, the formula for the heat capacity, the capital C is equal to Q over the chain of theta, where Q is quantity of heat and the chain of theta is the change in temperature. The unit for the heat capacity is joule over degree Celsius. Next, let's look at one of the situation here. When 2000 joule of heat is supplied to object A and B, object A experiences a rise in temperature of 1 degree Celsius and object B by 2 degrees Celsius. So the question is, what is heat capacity of object A and object B? Okay, from this question, we can use the formula to calculate the heat capacity of object A and object B. The formula for heat capacity is capital C is equal to Q over the chain of theta, where Q is the heat and the chain of theta is the chain of temperature. Okay, so the heat capacity for object A is 2000 joule over 1 degree Celsius, and we can get 2000 joule per degree Celsius, and the heat capacity for object B is 2000 joule over 2 degrees Celsius, and we can get 1000 joule per degree Celsius. So, the heat capacity for object A is 2000 joule per degree Celsius, and the heat capacity for object B is 1000 joule per degree Celsius. So in this situation, we can say that the heat capacity for object A is higher than the heat capacity for object B. So from this, we can make conclusion where the increase in the temperature of block A is smaller than block B. Let's look at the next situation. A pail of water from a swimming pool has been left for several hours beside the pool. The question is, which water is hotter? Let's think first. The answer is the water in the pail. Why? Why we cannot say the water in the swimming pool is hotter than the water in the pail? Because the quantity of the mass. The mass of water in the pail is smaller than the mass of water in the pool. So it takes shorter time to heat up than the water in the pool. Okay, the next question is, which water has smaller mass? The answer is water in the pail, as I mentioned just now. Okay, the next question is, which water needs to be exposed to the sunlight in a longer time in order to raise its temperature by 1 degree Celsius? So let's think, which water needs to be exposed to the sunlight in a longer time? The water in the pail or the water in the swimming pool? Okay, the answer is the water in the pool. The next question is, which has larger heat capacity, water in the pail or water in swimming pool? So the answer is the water in the swimming pool. This is because the water in swimming pool has larger quantity than the water in the pail, so it has larger heat capacity. Now we can make a relationship between heat capacity and the temperature rises of a substance. The relationship is the higher the heat capacity, the lower the temperature rises. Next, let's look at the factors that affect the heat capacity, which are the mass and the type of materials. So let's look at the mass first. The diagram shows two different sizes of bowl, where the big size of bowl has the larger quantity of soup and the small size of bowl have the less quantity of soup. The situation is, after being left to cool for some time, the soup in a larger bowl is hotter compared to the same soup in a small bowl. This situation means that the soup in the bigger bowl takes a longer time to cool down than the soup in the small bowl. Okay, why this happen? Because the big bowl has a higher heat capacity compared to the small bowl. When we say higher heat capacity, it means that it is hard, it takes a longer time to heat up and take a longer time to cool down. While when we say the lower heat capacity means it takes shorter time to heat up and shorter time to cool down. So in this situation, the big bowl has a higher heat capacity because it takes longer time to cool down. Okay? Okay, next, let's look at the type of material, which is one of the factors that affect the heat capacity. Okay, the diagram shows the dashboard and the cushion. Okay, the dashboard of a car has a lower heat capacity compared to the cushion. The absorption of heat energy from the sun causes the dashboard to experience a higher rise in temperature compared to the cushion. Now, let's investigate the specific heat capacity. Here I have three blocks, which are block A, block B, and block C. Block A is 1 kg of aluminium, rise temperature by 1 degree Celsius. Block B is 1 kg iron, rise temperature by 1 degree Celsius. And block C is 1 kg plumbum, rise temperature by 1 degree Celsius. So we can say that the mass of all the three blocks is the same and the temperature of the three blocks also is the same. Okay, now I want to heat up the blocks to make the temperature rise by 1 degree Celsius. For aluminium, I need 900 joule to rise temperature by 1 degree Celsius. And for iron, I need 450 joule of heat to rise the temperature by 1 degree Celsius. And for plumbum, I need 130 joule of heat to rise temperature by 1 degree Celsius. So, can you tell me which one of the blocks have the lower specific heat capacity? Okay, the answer is block C because it takes shorter time to be heat. And the one with higher specific heat capacity is block A because it takes longer time to be heat. Okay, the different quantity of heat is needed to raise the temperature by 1 degree Celsius for the three objects A, B, and C, even though their mass are equal. This is because the three objects are made from the different material. Different substance has different specific heat capacity. Let's look at the definition of specific heat capacity. Specific heat capacity is the quantity of heat required to raise the temperature of 1 kg mass of the substance by 1 degree Celsius. The keywords that I have highlighted here is the quantity of heat required, the mass, which is 1 kg, and the temperature, which is 1 degree Celsius. The formula for the heat capacity is smaller c equal Q over M delta theta, where Q is quantity of heat, M is the mass, delta theta is the change in temperature, and the unit for C is joule over kilogram degree Celsius. Next, let's look at the question for specific heat capacity. What is the meaning of the specific heat capacity of aluminium, which is 900 joule per kilogram degree Celsius? This question requires us to give the definition of the specific heat capacity of aluminium. So the answer is 1 kilogram of aluminium needs 900 joule of heat to raise its temperature by 1 degree Celsius. The next question is, What is the meaning of the specific heat capacity of water, which is 4,200 joule per kilogram degree Celsius? This question is the same as the first question, but it used the different type of substance, which the first question used aluminium. The first question want we to define the specific heat capacity for aluminium, and the second question require us to define the specific heat capacity of the water. So, the answer is 1 kilogram of water needs 4,200 joule of heat to raise its temperature by 1 degree Celsius. So this is how we define the specific heat capacity based on the type of materials. Next, let's answer the questions for this topic to test our understanding. The questions are: state the meaning of specific heat capacity of cooking oil, which is 1,850 joule per kilogram degree Celsius. Number 2. How many joules of energy are required to raise the temperature of 100 grams of coal from 20 degrees Celsius to 100 degrees Celsius? Given specific heat capacity of coal is 300 joule per kilogram degree Celsius. In this question, you can use the formula of specific heat capacity to find the energy. Okay, you can pause these videos to answer the question. Okay, that's all for today. Thank you.